Aerospace engineering has been a great enabler as a discipline, spawning progress in practically every other discipline. When Kennedy said, we'll put a man on the moon and
Yeah,
bring him
again, a
back
man on the moon.
home safely,
Man on the moon.
we're quoting his words. It spawned progress in everything from electronics, controls, material science, design of mechanical systems, hydraulics, communications. All of these fields were enabled by a large aerospace project. What is that one large aerospace project that you see, either globally or in India, that will require this expansive breadth of engineering and science expertise?
I think the specific question that you're asking is which will actually shatter barriers in science and technology, right? The reason why I'm actually specifically getting back to highlighting that is, for example, within the aerospace community around the world, there is a very well thought out plan for consistently and periodically sending humans to Mars, exploring Mars and settling Mars, creating like a biosphere there for humans to settle there and explore. All of that with just about current technology, just using the current day rockets to get there and all of that stuff, right? Not much in terms of having to break barriers. But the one that will actually break barriers for me is if I were to actually do a hypersonic flight. And the hypersonic flight is important for me to use air in the atmosphere in an engine that will burn fuel in a supersonic manner, right? So where the flow of air is still supersonic inside the engine, and so we call this the supersonic combustion ramjet or a scramjet, and economically transport people across the globe to the other side in let's say about 4 hours or so. So if I were to actually go from Chennai to San Francisco in 4 hours in a very affordable manner instead of having to use rockets and go through lots of G forces, going out to outer space and then re-entering and all that stuff without any of that kind of circus, and just want to gently go within the atmosphere and guzzle air from the atmosphere and burn. That's actually requiring materials progress in terms of the boundary layer heating to be withstood, the supersonic combustion, the materials to withstand those for long periods of time, and all of those things. So I think that's really what's going to make a big difference.
So the broader discipline of aerospace engineering borrows from practically all other disciplines. One of the first things we talked about is strength of materials. We're now back to strength of materials again. So in some sense, hypersonic flight or any air breathing engine that's going to be economical, the next generation will borrow from all disciplines back again. And that's the one big grand project that I think this generation of young men and women should be motivated by. How can we move people from, as you said, Chennai to San Francisco in 4 hours economically? I think that's a great calling for the next generation of people to build upon technology wise and make a difference to the way we connect.
The good news is the elements of these technologies actually exist, even within India. I think it's just going to take a focused effort to put all of that together and scale to what is required for like a certain number of passengers to go from here to there.
So we talked about where the world is in aerospace engineering and aeronautical engineering. We hear in the news from time to time the exploits of SpaceX and Blue Origin and all of these, I'll say, large space tech startups. They're no longer small, and some of the ideas that they're pursuing, like a completely reusable launch vehicle, are in themselves revolutionary. And I'm sure the day is not far when we will begin to experiment with them here in India as well.